Good morning. I am Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. And today, in our video lecture series, we are going to discuss about the topic S-matrix representation of waveguide, corner, bends. This video lecture series, which is comes under the Unit 1, Microwave Passive Devices. So, come, let's dive into the topic. So imagine water flowing through the pipes. So smooth flow, water moves effortlessly through the straight pipes, and the flow changes. Winds causes splashing, reflection, and shadows. So this is just for imagination to understand the bend, corner, and twist. And what is an S matrix? So S matrix is nothing but of a complete map of a traffic between the ports is called a S matrix. There we can get a traffic report, energy distribution, and port mapping, everything. And straight versus bend waveguides. Bend causes reflection and transmission. S matrix captures this behavior. So that's why we need to know about this S matrix, particularly about the S matrix and the properties in the previous episode we have discussed. So this is the meaning of this one. And modeling corners and bends. So break into blocks. Complex shapes become simple black boxes, and define ports, mark input and output connection points, assign S matrix. Each box describe the internal operations of the microwave systems. So visualizing with color-coded arrows. So here, waveguide S matrix visualization. Here, port 1, port 2, port 3, port 4. That is indicated with different color visualization. So blue arrow, which means that the incoming wave enters port. Red arrow, outgoing signal or reflected or transmitted signal. So that is the some visualizing example for the waveguides. So in this image also you can see the ports. So if you see the ports would be like this only. So port 1, port 2, port 3 and port 4. Each port will be used to send the signal, and receiving signal and reflection may happen based on the properties of the waveguide. So light in a hallway with mirrors, S matrix predicts how much light bounces back and passes through. This is the very important thing. So from that, I said already, the microwave passive devices, we have several passive devices like direction coupler, isolator, waveguide, twisted corner pins, and like that. So on all those things, we can study the theoretical concept by how it is operating, how it is behaving for the signal. But to predicting the correct actual behavior of the signal by means of only S matrix, we can able to do that. So that's why we are giving importance to the S matrix. So here in the micro passive components, so we will be studying, for example, if any one passive microwave device is taking the passive device operation. First step we will be studying, and after that we will derive the S matrix according to the behavior of the passive device. That is the concept we are going to discuss about the topic in this unit. So measuring and validating real waveguides. That is, first send signals, send test signals. So controlled input as at ports, and measure response. So measure response means reflection and transmission, and compare and refine. Validate predictions. So this is the importance of measuring and validating the real waveguides. Why design thinking matters here means, so in empathy, define, ideate, prototype, test, we formulated the concepts, this S matrix for bends and twist and corner according to the design thinking base only. So understanding waves like everyday fluid flow, and frame problem wave as a traffic control, and ideate part model bends as simplified connected blocks, and prototype visualized interaction with arrows and colors, and testing validate the real measurements. And as matter the key to smooth waveguide journeys, minimize signal loss and reduce reflections. These are all the important thing why we are going for this. Um, that is a S matrix. And coming to the mind map, a schematic representation of waveguides, which we studied core concept modeling process, that is ideate, visualization, prototype, validation, test, then design goals and design thinking approach. Thank you.